Welcome to the next edition of Chatting with Chuck. I'm your host, Chuck. Today I'm talking with Mark Lockus from Avantech. And speaking of Avantech, Mark, they still seem to have quite a few serial RS-485 based products. Isn't RS-485 somewhat a legacy product?
Yes and no. There are still industrial automation devices being designed and manufactured with serial RS-485 interfaces. Most industrial PCs are still manufactured with at least one RS-485 port, although multiple USB 3 and high-speed Ethernet ports are also commonly found on these computers to support the higher communication speeds demanded by newer technologies such as vision. Actually, Ethernet evolved from RS-485 and RS-422 serial communication technology. All of these use twisted pair technology, which is twisting two conductors carrying the same signal together in a cable. The serial signal on each pair is called a differential electrical signal, which can be thought of as identical electrical signals with opposing polarities, which makes it more immune to electromagnetic interference in the atmosphere. One of the earliest Ethernet technologies, called 10-base-T, started out with a maximum speed of 10 megabits per second. A little known fact is that RS-485 standard has a maximum transmission rate of 10 megabits per second, the same. The interesting thing about this is that at 10 megabits per second, the maximum length of an Ethernet twisted pair cable is 100 meters, or 328 feet. And for RS-485 at 10 megabits per second, it is the same, a maximum length of 100 meters. Ethernet really never goes slower than 10 megabits per second, but for RS-485, the speeds are typically much slower, usually in the range of 9,600 bits per second or 19,200 bits per second, sometimes called 19.2K baud or 96K. At these lower speeds, RS-485 can communicate over cable lengths of up to 4,000 feet or 1,200 meters between devices.
That really is an advantage. You say Ethernet can have a maximum cable length of 100 meters between devices, and RS-485 can have a maximum cable length of 1,200 meters between devices. So, Mark, what do you mean by devices?
Well, by devices, I mean things that amplify the signal again or are an end device. In Ethernet, this is typically a switch, which actually does not amplify the signal, but receives the signal, does various amounts of processing to the signal, such as deciding which port to send the signal back out of, and then sends the signal again at full signal strength. In RS-485, there is a device typically called a repeater. This device also does not really amplify the signal, but receives the signal and sends the exact same signal on again at full signal strength. However, this signal can go 1,200 meters or 4,000 feet before another repeater is necessary. For instance, the Avantech RS-485 repeater is the Atom 4510 series of modules. End devices are simply the final receiving device at the end of a network. For instance, the Avantech RS-485 I/O module, such as an analog input module, the Atom 4017, could be an end device.
When you say the end of a network, does that mean that both the Ethernet and RS-485 use networks?
Yes, but these networks are a little bit different. With Ethernet, typically switches are used to connect multiple devices and to extend the network more than 100 meters. So Ethernet can typically be thought of as a star network. That is, it branches off of its main feeder. But RS-485 is typically linear. That is, it typically connects using a daisy chain method where the twisted pair cable may be coming from the master device to a first slave device, and a second set of twisted pair wires are connected to the very same terminals going to a second slave device. There are ways to make an RS-485 network a tree network with branches using something like the Adam-4510 repeater we just talked about. But basically, it is a linear network. That is, one slave module after another in a line of daisy chain connections. RS-485 is also more limited in the number of devices that can be connected on the network than Ethernet as well. The RS-485 standard basically stipulates that the maximum number of nodes on the network is 32. However, RS-485 UARTs, which are the chip that does transmitting and receiving, have developed chips that support up to 256 nodes, such as chips used in the Advantech 4000 series remote I/O modules. But even in Advantech's expanded RS-485 network capacity, it is still no competition for Ethernet's capacity for devices using IP addressing. Just with IPv4, the limit was just over 4 billion addresses. So RS-485 has limitations of communication speed and the number of nodes on a network, but RS-485 has a huge advantage of much longer distance between signal amplification devices, such as switches or repeaters.
So you say communication speed of the RS-485 network is significantly slower than the Ethernet network. Can you give me a real-world performance comparison of using one network versus other for remote I/O?
Sure. Let's compare the performance of the Adam 4050 to the Adam 6050. These are very similar modules with respect to their I/O configuration. Both have multiple digital input and output terminals. The Adam 4050 is RS-485 based. The Adam 6050 is Ethernet based. The Adam 4050 uses serial RS-485 Modbus RTU communication protocol. The Adam 6050 uses Ethernet Modbus TCP protocol. If we connect both as a single module, that is ad hoc, meaning a single module connected peer-to-peer to a master, and we use a single industrial computer as the master, and we wrote a simple program that would poll the module for the status of a single digital input channel using the respective protocol through the respective port, we would expect a response in about 5 milliseconds from either module. So you might ask, where is the performance difference? Well, the rate of communication in this ad hoc configuration is not the communication latency, but rather the speed with which the module is able to process the pull request and respond with the requested data. But if we increase the size of the network to multiple modules, the speed difference would become evident. The reason is the way RS-485 works versus Ethernet. The RS-485 master, that is the industrial computer, polls the number one slave device, let's say of the state of the first digital input channel. It then begins to wait for the response and will wait until a specific timeout period occurs or until the response arrives. However, with Ethernet, the master does not wait for the response. It may immediately poll the second slave device. Why doesn't the RS-485 master simply poll a second device in the RS-485? Because of the way RS-485 works. RS-485 both transmits and receives over the same twisted pair, whereas Ethernet uses two sets of twisted pairs, one for transmit and one for receive. In RS-485, once the master transmits a request, the RS-485 network must remain quiescent. That is, all RS-485 transmitters are shut off until the corresponding slave has had the chance to respond. This is typically called half-duplex communication. That is, in one direction at a time. Whereas Ethernet is full duplex, or transmit and receive simultaneously. This half duplex mode is what adds significant latency to RS-485. The technical reason that the RS-485 network must be used in half duplex is because the UART chip, that transmit and receive chip, in the transmit mode takes the twisted pair communication lines to low impedance. If two UART chips go into transmit mode simultaneously, it disrupts the signal and communication is lost at that point. Advantech uses a timing method to ensure this does not happen, which shuts down the UART transmit mode once a packet has completed for 1.5 packet lengths. Using this method increases reliability, but also increases latency. All of these factors contribute to lower speed performance of RS-485 over Ethernet, but in many applications, the speed of RS-485 is more than adequate and very reliable.
So, Mark, then, what are some applications where RS-485, I should say, has made more sense to be used than the Ethernet?
Well, this typically involves the need for long cable runs without any amplifying device and the need for high level of electromagnetic noise immunity. One application where Advantech 4000 series RS-485 remote I/O was used was for airport lighting. Obviously, runways are a physically very long stretch with lights that can be far apart. Airports are also particularly plagued by thunderstorms. The Atom 4000 has worked well at several airports for these reasons, and latency doesn't matter much in something like airport lighting. This is also true for snow gun control on ski slopes, far apart, exposed to lightning. Again, the Atom 4000 series has worked well at several ski resorts.
Well, Mark, I really appreciate you taking the time to talk about this RS-485. It has been really insightful, and once again, thank you for being here. This has had Chuck with Chatting with Chuck. Stay tuned for further episodes.